Welcome to this tutorial on universal functions in NumPy. Universal functions, or Ufuncs as they're commonly called, are one of the most powerful features in NumPy that enable incredibly fast array operations. Let's dive in and understand what makes them so special. So what exactly are universal functions? Universal functions are specialized functions that operate element-wise on arrays. This means they perform operations on each element of an array individually, but they do so using fast vectorized operations instead of slow Python loops. The key benefit is speed. These functions are implemented in optimized C code under the hood, making them extremely efficient for numerical computations. Let's compare the traditional approach with the Ufunc approach. On the left, we have the slow loop-based method where we iterate through each element, square it, and append to a result list. This is the way you might naturally write code in pure Python. On the right, we have the fast Ufunc version using NumPy.square. This single function call handles all the elements at once using vectorized operations. The difference in performance can be dramatic. Ufuncs are often 10 to 100 times faster than equivalent Python loops. NumPy provides a rich collection of universal functions organized into several categories. Mathematical Ufuncs include basic operations like add, subtract, multiply, divide, as well as power and square root. Trigonometric Ufuncs cover functions like sine, cosine, tangent, and their inverse functions, plus utilities to convert between degrees and radians. Comparison Ufuncs let you compare arrays element-wise using functions like equal, not equal, greater, less, and logical operations like logical and illogical or. Finally, special Ufuncs include exponential, logarithm functions, absolute value, sine, floor, and ceiling operations. Universal functions come in two main types. Unary Ufuncs operate on a single array. Examples include NumPy.square root, which computes the square root of each element, NumPy.absolute value for absolute values, and NumPy.exponential for exponential calculations. Binary Ufuncs operate on two arrays simultaneously. For instance, NumPy.add combines two arrays element-wise, NumPy.multiply performs element-wise multiplication, and NumPy.maximum returns the element-wise maximum between two arrays. Understanding this distinction helps you choose the right function for your specific needs. One of the most powerful features of Ufuncs is their ability to work with broadcasting. Broadcasting allows Ufuncs to automatically handle arrays of different shapes. In this example, we have an array with 4 elements, and we're adding the scalar value 10 to it. The Ufunc automatically broadcasts the scalar across all elements, adding 10 to each one. You don't need to manually expand the scalar into an array. NumPy handles this intelligently. This makes your code cleaner and more efficient. Let's summarize the key benefits of using universal functions. First, speed Ufuncs are implemented in highly optimized C code, making them significantly faster than Python loops. Second, simplicity, they allow you to write cleaner, more readable code without explicit loops. Third, memory efficiency. Ufuncs support in-place operations, which means you can modify arrays without creating unnecessary copies, saving memory. And fourth, broadcasting Ufuncs automatically handle shape matching between arrays, making complex operations simple and intuitive. To wrap up, universal functions are the backbone of efficient NumPy programming. They enable fast vectorized operations without the need for explicit loops, support intelligent broadcasting for arrays of different shapes, and offer superior performance through their optimized C implementation. Master Ufuncs, and you'll master NumPy efficiency. Thanks for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.